Let us solve another good numerical problem in physics from laws of motion. Problem number 33 from Newton's laws of motion from the textbook Concepts of Physics by Professor HCVerma. And this one in particular is not meant for JEE main. It is rather meant for JEE, not for JEE main, for JEE advanced. Because the problem will be slightly lengthy because we'll have different forces. Now if you look at the statement of the problem, find the mass m. Now which is mass m? This mass is m. Let me write it red. This mass is m, and this is hanging. This is hanging mass m, which will prevent the smaller block. This is the smaller block. Let its mass is small m, slipping over the triangular block. This triangular block also has a mass. Let it be m dash. This m, I have shown it here to draw a free body diagram, and this m, I have shown it here to draw a free body diagram. Now what should be the value of this mass, so that this smaller block, this one kept on the ways having mass m dash, this will not slide down. Now means this will be prevented from sliding down, and this angle, let this angle is equal to theta. Let me show it here. Now what is to be understood is like this. Suppose in the given situation, in this situation, the whole situation is in equilibrium. Suppose, means this mass m is not falling down, and the string connecting with this mass passing over the pulley, which is connected to this triangular block, is also therefore not moving towards right. If this does not fall down, then this triangular block will also not move towards right. So in that case, what will happen? The component of its weight, this mass m, will try to slide down. So let me draw it. So the weight of this mass m from its center of mass is acting to this side, is mg. Now since this angle is theta, this is 90, so this is 90 minus theta. Now this is 90 minus theta, so to that if I add theta to this side, then this will be perpendicular to this. So the component of mg to this side will be mg times, this one will be mg times cosine theta, and the component of this mg, weight mg, along the inclined plane and down the plane to this side, let me draw it, to this side will be, to this side this will be, this one will be mg times sine of theta. So the component of mg, one is this mg times cos theta, this is mg times sine theta. So if this triangular vase is not moving towards right, if this capital M is not falling down, then this smaller block having mass small m will be moving to this side due to mg sine theta, which is a force. If you eliminate m from here, then g sine theta is the acceleration to this side. Now, so what will happen? Under what condition this mass small m kept on this triangular ways having m dash will not separate, will not slip over this triangular ways? If this whole system, this m dash and m move towards right with the same acceleration, then this M will not be separated from M dash. Means M will not, if both of them move towards right with the same acceleration, then this small block M will not slip over this M dash. So that is the concept to be understood, because if this whole system moves to this side, if this triangular wedge moves to this side, this M will experience a force to this side, and if this force is equal to this force, then this block of having mass M will not slip over on this triangular wedge having mass M dash. So let us now draw the free body diagrams for each of them, for this as well as for this, to solve the problem. I have taken this M dash separately here to draw a free body diagram for it. I have taken this separately here to draw a free body diagram for this. I have taken this separately here to draw a free body diagram for this. Now suppose this M is falling down, so its weight is acting vertically downward, and this will be M times G, and this is the string, that is the tension T. So if I draw it here, this is your M times G, and that is being opposed by the tension T. So for this block, that is same thing as this block, if it is coming down with acceleration, then the value of mg must be more than the tension T, which is opposing it, to come down with acceleration. So for this mass, the equation will be mg minus T is the net force downward. It will be mass times its acceleration. Now let me bring this term to the left hand side, so this becomes mg minus T minus m of A is equal to 0. Make it equation of 1. Now then let us come back to this triangular wedge. This surface is smooth, so there is no friction. The string, the pulley, they are also massless. Now this triangular wedge having mass m dash will have action force here, vertically downward, but I am not interested in that, and this will be vertically downward. And how much will be that? That will be m dash times T is one weight. But since this is vertical and this does not have a horizontal component, so this does not contribute. So sorry, it's not visible too. This triangular wedge having mass m dash, which I have shown it here, will have a force downward its own weight, that is equal to m dash times G, because since I have taken its mass as m dash. But this will not contribute to the motion of this triangular wedge towards right, because this is vertical. Now, so let us not consider it. Had there been friction here, then I would have considered it, because I would have considered this for force of friction as mu times normal reaction. But since this is not contributing towards its motion towards right, so I am not considering it. Now, then what I have to consider, look at the point of contact. The point of contact between the small block of mass m and m dash. I consider a point of contact here. There will be some action force. Normal to this surface, Let me show it here like this. Action force, and the same reaction force will be applied on this mass M towards this side, which I will show it here also. So let it be, and since both are equal, let me take it as R. Now this angle is given as theta. Now let us resolve this R into two rectangular components such that we get now one component like this and another component like this. Now if this angle is theta, let me produce it. Now here this is 90, so this will be 90 minus theta, and since this is normal to this line, therefore this will be theta. So this component of R will be, let me write it here, it will be R times sine theta, and this component will be let me show it here, will be R times cosine theta. Now what else? Now if you look here, this tension for this block is away from it, and the same tension in the same string for this triangular waves having mass m dash will be to this side. So I have to show that here also. So I have to show that here also. So I have to show it here also. So now if you look at this triangular waves having mass m dash, and it is moving towards right, so along this direction there are two forces. T is towards right, and that is being opposed by r sine theta, and no other force along the horizontal direction. So for this mass, the equation will be T minus this, that is r sine theta. R sine theta is the net force towards right, so that will be its mass times acceleration. So this is your equation 2. Let me bring it to the left hand side and rewrite it here as T minus of r sine theta minus of m dash a is equal to 0. Your second equation. Now we are only left with two more equations. Now look at this small m. Its action force on this triangular waves is to this side. So the same reaction force for the mass small m will be to this side. Will be to this side. Will be to this side. Let me show it in red. Will be to this side, and this will be one component, and this will be one component. Now the same r. This is theta, so this angle will be theta because vertically opposite. So this will be r sine theta. This will be r times cos theta. Now these two I am writing for the block of mass small m. For the block of mass small m, I can now if you look at small m, if you consider now this mass small m is here, that is pulled towards right due to r sine theta. So let me show this part here. So it will be convenient for you. So it will be convenient for you to realize the same reaction force Now the same reaction force, now R, and this I explained how this is theta, so this is equal to R times sine theta, this is equal to R of cosine theta, and its weight is acting vertically downward, downward. Where is the other pen? Okay. Is acting vertically downward, small m times g. Now, normally the students make mistakes while writing equations of motion, the free body diagram equations for this mass. Now, what do? They consider as if this T is also acting on this. Look, this T, because of this string which is connected to m dash. This string is not connected to this small m. So, T is for only this block m dash and for this mass, hanging mass m, not for this. So, for this, R sin theta is towards right, R cos theta is vertically up. These two are the components of R. So, if I forget this R, I have to consider the two components and its weight is vertically downward. Then two more equations. Now, since this mass is still resting on m dash, that is R cos theta is mg. So, I write it here. R of cosine theta is m times g, and this R sin theta for this block towards right, so that will be its mass times acceleration. There is no opposing force to this side. So I write it here. Your R sin theta is the net force, horizontal force on the small block of mass small m. So that will be its mass times acceleration. So make this as equation 3, make this as equation 4. And in a different page, let me write those 4 equations and then solve it. So your first equation is equal to mg minus t minus m of g is equal to 0. Your second one, t minus r sin theta minus m dash of a is equal to 0. That is the second one. And your third one is r cos theta. Let me write it here. R of cosine theta is equal to m times g, the small m times g. That was your 3. And your r sin theta, due to which the block of mass m has the same acceleration towards right as the acceleration of m dash. Therefore, m dash will not slip over, therefore m will not slip over m dash. Now, once that is understood, now we are left with only the algebra part of it. Let us divide the left hand side of this with the left hand side of this and the right hand side of this with the right hand side of this. So your RR cancels, cotangent theta, mm cancels, is equal to G over A. We'll use this value here. Now here, if you add these two equations, minus t plus t cancels. So m times g minus m times a minus of r sin theta minus m dash times a. 0 plus 0 is 0. And r sin theta, I have just explained how r sin theta is mass of the small block times acceleration. So for r sin theta, I can substitute MA. So let me rewrite this here. So mg minus m of a, for r sin theta, I write m of a, the small m, minus m dash a is equal to 0. I am interested to find the value of this mass such that this small m, which is kept over m dash, does not slip. So the terms containing m here and here, I keep it on one side, that is mg minus m of a. The rest two terms I take it to the other side, so both becomes positive, ma plus m dash of a, and if you take a common, we are left with m plus m dash within bracket. Now if you take m common here, we are left with g minus a. Now I am interested to find m. So g minus a is multiplied here, goes to the other side, so it will be divided. Of course your a is here, this goes to this side, g minus a. Now if I bring this a to the denominator, so let me rewrite it like this, m dash plus m looks good. So a will be divided here and here, so equal to g over a minus a over a, and g over a, I explained you how this is equal to cot theta. So for this I write cotangent theta minus a over a is 1. So I began from here, I arrived here. So the value of, so under this condition, if the value of this m, that is this, is like this, means the sum of the mass of this vase plus the mass of this block over cotangent theta minus 1, then this small block having mass small m will not slip over the mass m dash, right? Now, so what else you can analyze here? Now, if this value is more, then this value will be more. If this value is more, then this value will be more. Now, and if you look at the denominator, if this value is less, for a given value of m dash and m, then the value of the fraction will be more, then the value of m have to be more. So that is all about. I hope it is clear to you. This is a good problem, but not for examinations where the duration for one question is 1 minute. It will take more than 5 minutes. So you can expect this kind of questions in JEE Advanced. Okay, thank you.